Hello everybody, welcome to Laser Munich 2023. I'm here at the ID Quantique booth in Hall B2, number 104, and here we are demonstrating our laser target practice live demonstration. So as you can see, my colleague Mark Nikle will be trying to couple laser light from our short pulse laser into our single photon detector called the ID Qube using this free space manual setup. And the entire experiment is coordinated by our ID1000 time controller, which you can see how this all works on the screen, which I'm about to show you. When we start the experiment, you can see random noise is piling up on the histogram view right now. What this means is that the light that's coming into the detector is completely random in nature. However, when Mark couples the laser light in, as he will demonstrate now from our ID3000 short pulse laser source, we get a very defined peak within certain time bins. What we're really measuring here is just time of flight, but we can also see very clearly the instrument response function of all of the devices involved in this setup. So first he's going to couple the light in from very close, and you will see a peak appearing on the histogram at one time value. And when he moves backwards away from the target, you'll see a peak appearing in another location. And that is because we can very easily measure the speed of light using the ultra-precise time bins of the ID1000. Another thing that we can measure with this setup now is the instrument response function of all of the devices involved. And that's very easy to do with the ID1000 software. All we have to do is zoom in on our peak. We can easily display measurement. So we'll set it to the full width, roughly half maximum. And so by doing this, we can measure the instrument response function. Here we can see it's 0.39 nanoseconds. However, if it was kept in one location during the whole measurement, it would be much smaller. And by going into the ID Qube software, we are able to change the quantum efficiency. So now we have increased the quantum efficiency of the detector. By doing so, we are also decreasing the timing jitter of the detector. And so as Mark will demonstrate now, when you couple the light in, the peak is much narrower. So he's going to couple some light in, we're going to get a nice clearly defined peak. And now when we zoom in using the GUI, we can see that this peak has a much narrower full width half maximum value on the order of only 180 picoseconds.